Cyclotron. Cyclotron is basically a particle accelerator used to accelerate charged particles or ions to very high energies. E.O. Lawrence and M.S. Livingston invented this for the study of nuclear structure in the year 1930. The cyclotron uses both electric field and magnetic field. The action of the electric field is to increase the energy of the charged particle. The magnetic field guides the particle to move along circular track. If V is the voltage applied and Q, the charge, then gain of energy while traversing the field is QV. This increases the kinetic energy. The magnetic field makes the particle to circulate with frequency nu equal to QB divided by 2 pi m. Construction and working. Cyclotron consists of a pair of hollow D-shaped metal chambers called the Ds D1 and D2. They are placed in an evacuated chamber with their diametric edges parallel with a small gap between them. Both the Ds are placed under the pole pieces of a very strong electromagnet, so that the magnetic field is perpendicular to the plane of the Ds. A high-frequency alternating voltage is applied between the Ds such that the electric field exists only in the space between the Ds. A source of iron, S, is placed at the center of the gap between the Ds. When a high-frequency AC is applied between the Ds, an alternating electric field is set up which will make them positive and negative alternatively. Let an ion of charge plus Q is emitted by an ion source at the instant when D1 is negative and D2 is positive. Then it is accelerated towards D1 with a velocity v1. It describes a semicircular path of radius r1 inside D1. At this time D1 becomes positive and D2 negative. The particle will be accelerated towards D2 by the electric field between the Ds and it enters D2 with a higher velocity v2. It describes a circular path of higher radius r2 inside D2. When it completes a semicircular path in D2 again the polarities of the Ds get reversed. Again the particle moves towards D1 and accelerated by the electric field. This process repeats and the particle is accelerated each time it crosses the gap between the Ds. It describes a spiral path of increasing radius and finally comes out with a high velocity through a small hole and strikes the target T. For the proper functioning of the cyclotron, the cyclotron frequency must be equal to the fixed frequency of the applied AC. Applications. There are basically two applications for the cyclotron. It's a particle accelerator, and, though it can be adapted to accelerate any charged particle, it is most frequently applied to accelerate positive charges. Protons are frequently the choice. We use the cyclotron in the physics lab, and in medicine.